Howdy, folks. Today I thought I wanted to work on a little bit of a project, kind of from start to finish, just to see how that worked out. Sorry, I'm trying to get my chair in a position. Just see how that worked out, just to see how kind of we could work through and practice some of the stuff that we've worked on over the class. And actually, let's see, project or practice. Set that up. All right. So, what I planned on doing, let me bring this up, is there was something I had watched a video about the other day called a wave function collapse, and someone was using it to build custom maps and build like kind of maps that went on forever. And I want to take a look at that. So let me just see. Wave function collapse. Wave function collapse algorithm. Yeah, so this is apparently a thing. And let me just make sure. Yeah, so basically the idea is you take something that starts off looking like a source image, and then you have an algorithm that basically uses that to build things that look kind of like that source image but aren't exactly like it. And so it's kind of cool. Like you can see, like if you start off with here with this is like a dungeon room, a room of 4 dungeons. Here's a couple things that they can create, and it's not completely it's not always very perfect. Like you can see there's a room here that's just not connected to anything. For stuff like plants, it's kind of cool. You get these cool looking plants off of the sample image. And so the idea, at least as far as I understand it, let's get out our trusty MS Paint, is if you start off with a couple of rules, right? And you can have an algorithm that can figure out those rules automatically, but you can build them yourself. Like let's say we have a couple of different tiles, right? So let's say we have mountain, and I'm just gonna, we have a mountain tile, right? And then we have, oops, you know what I actually want? I want this to be black. Here we are. And then I'm gonna copy that. So like maybe we have mountains, which are that gray, and then we have like some ocean, which is a blue, and I'm like legitimately cribbing this video at this point, and I have like some sand, some kind of like maybe golden sand, right? And then we have a forest, which is going to be this lovely color of green. And so we have some rules here. Let me just put this up here like this, and we'll put some titles on them. Mountain, let's make that black. That's not black. Text. How's mountain spelled? Mountain. Ocean. Forest. And a beach. And now if we look at like maybe some rules here. Mountain must be next to forest. Okay, like so you can't have a mountain next to an ocean. Forest can be next to mountain or beach, and ocean can only be next to beach. All right, so there's our rules. So we have some very simple rules here. A nice little setup with that, and we have our different tiles. So then the idea with this is that you start with a specific tile, like let's say mountain, and then you ask it, what is the tile to the left of this? Well, the tile to the left of that has to be a forest, right? Because our rules, mountains must be next to forest, so we put a forest tile there. Then we go to the, I guess it's to the right. We go to the right of that, and we say, well, what's that? And well, it could be another mountain, it could be a beach. Now we have an option. We can choose. Maybe we say, oh, okay, maybe we pick a beach tile. Okay, and we put that there, and we go up here and we say, well, that's another mountain tile, right? And so then obviously this one has to be a forest. So this is kind of a way of building a random map, essentially, based on trying to figure out what you have and what needs to be placed there. So I kind of want to try to build something that does this. I think that'll be kind of fun. It'll be a good good use of some of the skills we've learned, and also it's just kind of useful. So let's get started. I'm going to start off. Whoa, that is not what I'm going to start off doing. Okay, I want to pull the terminal over, not the entire window. There we go. Okay, so we start off with our terminal. Let's go to, let's just go there. And then I'm going to do this in React just because, you know, we've learned React. We might as well make some use out of it. I'm going to build an app. We're going to run, let's call this Wavefront Collapse. Wavefront Collapse. Okay. We're not going to do that for now. We're not going to do a backend. Okay. And install. Let's get everything installed here. And let's just open it up so we can take a look at our code. And if anyone has questions, you know, as we're going, just please let me know. Including if you joined late and have no idea what I'm actually doing. Did that do that install? No, it's still in the process of installing. So basically, if we're doing a map, we need to be able to represent that map, right? And a map in here, just put this another forest tile in here, is a grid. And you can have you can have hexagonal maps. You can have maps that are triangles, but in the end, even a hexagonal map, it turns out, can be stored in a grid structure. It's just kind of displayed a little differently. I've built hexagonal maps. That's how I know that. So we really have, let's say we have a 10 by 10 map, right? That's an array of 10, but then we need 10 of them. So we there's a couple ways we can handle that. We can do it with a multi-dimensional array. So we can have an array of arrays. So what that would look like, let me just go in here, make this a little bigger so that you all can see. View appearance, zoom in. So we could do something like this and have some other rows in here, right? And so then maybe I could have forest, mountain, forest, beach, water, beach, etc. And that's one row. And then I go down a row and I say, well, let's make this also a beach. This is going to be a forest. This will be another mountain. This will be a forest. This will be, well, I guess I can't do water there. Something like that. And we just keep doing these rows, one for every single map, one for every single row in the map, right? So that is one way to represent a grid-based map, is as an array of arrays. So we have this array and each one inside it has a specific list. So this would be like a 2x6 map. The other way you can do that is you can do it as a single array. And so I'm just going to grab this, put that in there, put that in there. And then you have like a row size of 6. So then if you have an index of 3, then you can kind of use some, well, I guess this would be 3. We can use some extrapolation to figure out that that's in row 1. Whereas if we go all the way over here, we know that this is above 6, which means it must be in row 2. This is a way that you more commonly represent data like this if you're working in a language that doesn't very easily, like where it's possibly expensive to create new rows. So like in JavaScript, we can do something like this. If I was working in C++, this would be a lot harder to do. So if in C++, I might actually do something like this particular option because it's easier on memory and it's a little easier to code, honestly. However, I'm not working in C++. I am working in JavaScript. So this is how I would choose to represent a map, simply because it makes more cognitive sense to me. And it's not actually going to make that big of a difference performance-wise. This will be totally fine. So that's why, anyway, I'm going to represent the map like this. Let me see if this is finished installing. Yeah, it's finished installing. Okay, cool. So let me get rid of this. The first thing I want to do, if I'm representing any sort of data, is I need to have a place to contain that data. We have our React app. It's a very simple app here. Let me actually get it started. So if I am actually using Vite for this, because it's just seems like it's a little faster. And let's see, if I open up 8080, there we go. I have my basic component. My React app is set up. It is built. It's ready to go. So the first thing I need after getting this boilerplate set up is I need somewhere to store my map data. The generator will build a little later. I just want to be able to represent that data first, because the important part of any algorithm is that when you're building it, it's really useful to have a way to determine it's actually working. And so what I like to do in a lot of cases like this is I like to build the basic structure with some dummy data or test data, just to make sure that the visuals do what I want them to, because if the visuals do what you want them to, getting the algorithm figured out is going to be a lot easier because you can see what it's doing. And that can be kind of important to do. So I'm going to use a context for this. Now, I don't have to technically use a context. I could just put something in here and just use a state, right? I could have a state called map. But why am I doing it as a context? Well, a state is something that is inherent to the component in which it lives. So if I wanted to pass this map around to other utility methods or anything else, I would have to pass that state value as well. A context, on the other hand, lives at the top level of the application, and so it just provides data to the whole application. And so in cases like this, where you have some piece of data that might be valuable to a lot of the application, it's definitely a better idea to make it into a context as opposed to leaving it as a local state, because the local state is a little more limited. So over here in source, I'm going to make a new folder, and I'm going to call it contexts. A folder, you don't have to make a folder for this. I just like to. I feel like I'm going to sneeze. There we go. I like putting a folder for context just because I like to have them all in one place, and I like to kind of know where they are. It's just a good way of organizing your code. And I know we didn't get too much into contexts in the class, but that's a lot of times you put them in a specific folder like this just because they all meant to go together. So now that I've made my context folder, actually I'm going to zoom in again just to make sure that people can see. Now that I have my contexts folder, I'm going to create another file in it, and I'm going to call that. You want to name it something related to the kind of data it's going to store. So I'm going to call this the map context. Okay, map context. First thing I do in a context is I want to have two things. I want to define two things. I want to define the actual context, and I want to define a provider. So the context comes from React. So I'm going to import use context from React, because context is a React specific thing, because I'm using the React framework. I don't want to say it's a React specific concept because other frameworks might be doing that as well, but I'm using React, so I need to create a context in the React way. That is with a hook. So if you don't remember hooks, hooks are basically things. Oh, actually, you know what? I don't even want use context. That's wrong. Hooks are basically ways to store data or make decisions as React components render. It's kind of like there's the React lifecycle and various things that it's going through, and you can hook into those events, and when they happen, you can decide what kind of code gets run. So it's a little bit like an event handler in that way, though kind of more adjacent to it. All right, so yeah, I don't actually want use context here. I want to pull in React, and then I'm going to define my context, and that's as simple as map context equals react.createContext. And that is a function. Okay, so now that's it. I've created the context because React context doesn't have to be very heavy. It can be as light or as heavy as you want it to be. In this case, I've just said, hey, here's some context. Does it have any data? It does not. That's all right. I can utilize this now. So I'm going to export default map context. So remember what that does is it's kind of like here. If I want to import this later, I would import. Well, let me actually do it on the app. So now that I've got this map context here, I can go to app and I can say import map context from context map context. I can do that because I exported this as the default. So if you see that export default, import here. If I export something that's not the default, so if I exported const foo equals bar, for instance, I would have to import it like this inside the curly braces. Posting the announcement that it started. Oh, I thought I did that. All right, well, I'll post the announcement that it started. All right, I thought you guys would know based on the fact that we said it was going to be about 5 minutes late. But that's, that's fair. That is very fair. Give me a second to do that. I gotta get Discord up. There we go. All right. That has now been posted. Anyway. So yeah, export default means you import like this. Export const means you import like this, or export function. Anything that's export that's not a default, you have to put inside the curly braces like it's an object. And yeah. So I'm doing an export default on here. The next thing I want is I want a provider. And what does the provider do in the terms of the context? It's a little bit like if you're thinking about like a restaurant, for instance, the context is going to be the waiter. The context is going to show up and say, oh, okay, what do you need? What are you ordering? And then they'll take it back to the kitchen. The provider is the kitchen. The provider is what actually provides the data into the context. And I've seen a couple different ways of doing this, and maybe I'm a little old school, but this is how we've done it. Well, I don't know if you can be old school with context. It's barely been out for 3 years. But this is how I've done my providers. So first of all, I export a function called map provider. Okay. And what that's going to return, a context has its own provider attached to it. Okay. So I'm actually going to return map context.provider as a React component. And that might look a little weird. Like, oh, why is that doing that way? Well, that's just how the context system is set up in React. This has to be somewhere. Whatever is inside this provider basically gains access to all the data. Okay? So, where you put this, you can put this provider in your app at top level. I like to put it in the index. The reason I like to put it in the index is it just keeps it clutter free and out of the way. Like if I put it in here and I said, oh, let's wrap this in the map provider. And let's put our div in there. Okay. That is legitimate. You can absolutely do this. Sorry, now my indents are all off. You can absolutely do this. This is totally fine. Hello, population 0x. How's it going? Yeah, you can do this. The thing is, and in an especially large application, you're very likely to have more than one context. In one of the applications I've worked on, oh, Isaiah, good to see you, Isaiah. In one of the applications I've worked on, we had, I think, something like 15 contexts. So imagine 15 providers. And the way that React works is they often nest each other, right? So then you're going to end up with provider 2. And then this all has to go inside provider 2 because that's just how React works. Okay, so now I got provider 2, and then imagine doing that 10 more times, right? That is not going to work. It's not going to look very good. It's going to clutter your app. But there is also a function or a file that you don't really ever use, and that is the index. Oh, Isaiah, this is built using Vite, by the way. I'm using that as the rendering engine for this. Thought you might be interested in that. So instead, if you wrap it here at the top level here, this render, you could put any JSX in here. You could actually put your whole app in here. It's just we don't do that very often because it doesn't look very good. So I'm going to get rid of this here. Take out those providers from my actual app here. And then I'm going to put them in here. I'm going to say, okay, map provider. And I'm going to put my app inside that. All right. So now I can put all my providers in here, and it may make this file look a little cluttered, but it's not doing anything else. This file doesn't do anything else, and app is now very clean. I can just kind of magically assume that any data in the providers is available anywhere inside my app because it's available at the very, very top level. So now we've got our map provider. There's one other thing we have to do. Okay. We've got our app. And React, when you have a component like this and it takes in another component as a child here, that becomes a very specific property. And so what I'm basically going to do here, we have our props here, right? Every React component has props. Even at the very top level, there's nothing in those props usually, but you have props. And so props here, I'm going to destructure it into an object because that's just what we do for React. It makes it look a little cleaner. And I'm specifically going to ask for the children property. What is children? Children is going to be all of the elements that are inside, that I pass inside of it. So let me show you a bit of an example of that, okay? So let's say I have, I'm going to make a sample component here. I'm just going to call it thing. Making a new component, we import React. Most important thing, export default function thing. Okay. And then I'm just going to return some standard. This is a thing. It's a very standard JSX, right? This is a very simple component for right now. And then I'm going to put that in my app. Okay. Oh, because it doesn't like being top level there. Let's put it inside the div then. All right. So now we've got our thing component that prints out this is a thing. So if I go and look now in my code. Oh, what is it not like? Oh, see, this is a Vite thing. I made this as a JS file, and it should actually be a JSX file because apparently there's a way around that, but it's really a pain. Nope, now it doesn't like, oh, it doesn't like the map. Now it doesn't like the context. It has the same issue with the context. JSX. My only gripe so far with Vite, that JSX. Not something I'm used to. All right, oh, what happened? Right, that's why. Let me just take this provider out for now. We'll add it back in a minute. Oh, there's still nothing in there, huh? Oh. You know what it's complaining about now? It's saying, hey, let me actually pull in the console so you can see it. The respective module map context does not provide an export named foo. And that's completely reasonable. In app, I was telling it to pull in foo. It does not provide foo. We cannot do that. All right. There we go. Now it works. So here's our component. All right, there's our div. That is our thing component. It has that in it. Now let's say I wanted to put some children on this. I wanted to put like maybe another div in here. Because let's say thing now, I just want it to be something that turns stuff purple, you know? Maybe I want it to do that. So let's say if I go into here and I say, oh yeah, let's set the style, color, purple. You can't, you know what? Purple's kind of hard to see. Let's make it red. This is why I like red. There we go. So now you can see that's red. Files JSX are React only. So here's the thing about that. JSX, this is technically JSX. And if you're using Webpack, Webpack is smart enough to realize that JS files need to be run through Babel, and Babel will figure out for you that they have React in them. So the only reason this is happening is because I'm using Vite, and Vite apparently is not that smart about this. So it will not actually compile the React component appropriately unless I put it in a JSX file. And from what I understand, that's done for optimization. So if you have a large file that has no JSX at all, no React components or anything, Vite can be more efficient if you tell it specifically that that is JS versus JSX. If you're using Webpack, like if you're using Create React App, you don't need to do this. Now, if you do put JSX, Webpack should pick that up. It will also understand what that means. We never went over this in class because we didn't need to do it in class because we're using Webpack, and Webpack is smart enough to handle this. But it's just Vite understands this. So if I change this now to like just JS, and then I run, you can see I get an error. And it says, failed to parse source for import analysis because the object contains invalid JS syntax. If you are using JSX, please be sure to name the file with the JSX extension. So it gets to this part here, and it says, I don't understand what this is. Oh, hey, Dominic. I don't know what this thing is. And it's because specifically Vite has not run the JSX parser over this because it is not a JSX file. Again, Webpack does not have that issue, and there is a way to make Vite actually work the same way, but it's kind of a pain. It's kind of annoying to do. And it apparently makes it slower. So if I rename this to JSX, you can see now it's come back and it said, oh, now I know how to parse that because you told me what it is, right? It's kind of like if I decide to name this like .php, right? Now all of a sudden, Vite is gonna be like, dude, I don't know what the hell you're talking about. Like, what do you want me to do with this file? I don't understand this file. I am not a PHP compiler, and you just told me this is a PHP file. Completely fair. So the file extension, a lot of programs will very much look at the file extension to figure out what type of file they're dealing with. So it is sometimes important to get that right. Anyway, let's say now I've got my thing, and I've got some stuff in it, right? I've got some text, but then I decide, yeah, absolutely. Then I decide that I don't want to just have this one text. I want to have some additional text that I make red. In fact, I want to be able to kind of have whatever I put into this component be red. So like if I put in and I say, whoops, what's app? Here we go. Some different text. Okay. And then I go and check this. It hasn't changed. It's still the wrong text. It's still that old text. Because React does not magically take whatever I put in here and output it. Because React is not going to make the assumption on my behalf of where it should output that text. Now, here's the interesting part. If I actually pull in the children prop, and I'm just going to console log that for now, just so you can see what it is. You can see it becomes what I put into it. If I put in even like something else, like let's say I put a span text, okay? And I run that, you can see now that the children has two options in it. This, I don't think you can see this very well. Let me see if I can make it bigger. You can see now it has two. It has that some different text as the first child. The second child, this is actually what a React element looks like under the hood. You can see it is a type of React element. It has its own props. That is a span text, and it is a type of span. So the children property then is a special property that basically includes everything that is inside that component. Not every component you build needs to have children. Like app doesn't have any children. And thus I render it like this without those children. It doesn't need that closing app tag because I'm not doing anything with its children. It is what we call a self-closing tag. It doesn't have children. Thing, on the other hand, can have children. It handles those children. And so you can pass children into it. So instead, so if I said children here, instead of that previous text, and I look at here, now you can see this is all the children, and they've been turned red. And if I look at it in the inspector, here's our thing, the top of our thing component, and here's the children. At no point do we actually have this specific data or this specific structure in our code. Instead, we are using that children property. And what you can do with this is you can do a lot of things that are meant to wrap other data or wrap other components. Like, for example, in this case, I wrapped these components and made them red. And so anything I want to be red, I can pass it into this thing component and it'll be red without me making any extra effort. There's a lot of different things this can be used for. One of them, specifically, is for context. Because remember, whatever I pass in, whatever is the children of this provider, gets access to its value. So if I just pass the children in here, and children like this basically map provider now just wraps everything inside the context provider. And so this is it's basically a helper class. Again, we don't need it. We could have just taken this particular provider code and wrapped it around our app directly. But this provider provides us with a bunch of other useful stuff. Hey, Osama. And we'll get into that in a little bit. So we've got our provider here. Let's go back here. Map provider here. And then I'm going to put the app inside of that map provider. And the fact that now app is a child of map provider means that map is a child of the map context provider. And that's basically what that wrap does. Okay, so now we have a context and now we have a provider. Why did we do all that work? What is that useful for? Well, now we come into the part of values. And this is what makes context really powerful. So let's see. I have a value here. I'm going to do it. Well, you know, let's just do this. Foo. I use this too much. I use this enough to the point where I've searched old projects for foo to try to find out where I could delete something. And I've found it in more places than I've added it. Provider takes a property value like that. This value becomes available to every single child. I don't have to pass it in as a property to that child, which is important because I don't know what these children are, right? I created them here. And the reason is when I created this app, I don't know what the value of provider is. So I can't put it as a property on app. Because when I do properties, those properties are scoped to the index.jsx. Inside here, I don't know what the children are. So I can't provide properties to them, but I can provide this value. And here is where the context comes in, use context. I can say map value equals use context map context. Now remember, let's get rid of this. We exported map context. This is the default export, not this. That is this particular one. And React does some weird jiggery pokery to make sure that this particular provider here connects to this context, which is disconnected from this provider. And so you just provide these two things. The provider gets hooked up in your index, like this, and the context gets used in your component. Confusing? Yeah. But it doesn't get a lot more confusing than that. This is about the level of complexity that the context gets to. And you might wonder, why did they do it this way? I don't actually have a good answer for that. But something about the way that they built this internally necessitated that it worked this way. So let's console log map value. Okay. Now, if I look that up, look at my console, I get foo, right? Because that's the map value. Okay, that's not very useful, though. I could have just put foo as a thing in here. But here's the fun part. Thing has no properties from app. I can put the same code in here, which actually I'm going to let it import for me, map context. I can put the same code in here. This is not a something that is passed down from app. I did say what we're building, but it was very early on. I don't think anyone's here. So just to go over it again for everyone else, since that is a thing, there is the concept of a wave function collapse. And what the wave function collapse is it's a way, let me see, do I still have that? Let me bring up that thing again. There we go. The wave function collapse basically takes starting images and determines various rules from them and then allows you to generate larger images that are made up of pieces. So you can see like this looks like buildings and it can be used to generate random buildings. This looks like a plant. It can be used to generate a random plant. This looks like rooms in a dungeon. It can be used to generate random dungeons. And so there are libraries that you can use that try to figure out rules based on what we see here. I'm not going to build something that complicated because we don't have enough time for that. But what I do want to build is something a little bit more simple. Like you can see, this is something that was a wave function collapse. This is what we're going to try to build. So we have our 4 different kind of map tile types, right? Biome types. You have our mountains, our oceans, our forest, and our beach. And this is cribbing a little bit from the example that I watched on YouTube, but I thought it was really cool. Minesweeper is also very cool. Minesweeper is surprisingly fun to program, honestly. So we have our rules. Mountains must be next to a forest. And that's kind of how wave function collapse works, is it figures out rules of things that have to go certain ways. So for example, if I have a mountain here, the next tiles next to it have to be forest. That's just the rule. They have to be. Okay? If I have a beach, the beach can be next to a forest or an ocean, but not a mountain. Okay? A forest can be next to a mountain or a beach, but not an ocean. An ocean can only be next to a beach. So we're going to use those rules to see if we can build a random... I guess a mountain can be next to a mountain too. Yeah. It is. Yeah, this is basically procedural map generation is what we're going to try to do. And, you know, it gives us a chance to play around a little bit with React and some of those concepts. So I wanted to give it a try. But yeah, very, very much procedural generation. I like procedural generation. I think it's very interesting. Let's see. Where was I? So we've got our map value here. Value. And I'm going to take it out of app just for now. Now, if I look at my console, you can see, oops, let's just rerun this. I have that same foo here. I don't want to preserve. And this came from thing. So this came from a component that is nested inside the app. And the app never told it about that property. It got it from the context. So the context, basically everything you put in this value is available to everything in your application, no matter how deeply nested it is. And that's really valuable because what we used to have to do is we used to have to pass properties all the way down the chain. And if you had 30 components, sometimes that was really difficult. So that's the whole point of a context, is it takes data and makes it available to your whole application in a very easy way. If anyone has questions about that, let me know. No worries. I don't mind going over and explaining it a little bit. But these values are usually objects because you want to pass multiple properties. And so what I want right now actually is I want to have my map. So I'm actually going to do map as a state. Why am I going to do it as a state? Because that's how React tracks stuff. I could have something that was like map equals blah, 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 and then put it in here, map. The issue is if I modify map, it's not going to automatically re-render the application. Use state has that bonus where it will automatically re-render the application if it is changed, which is very cool because that works very well with React. So I'm going to have map, set map equals use state. And I'm just going to give an empty array for now. So with a context, sometimes you actually expose the set functions on your states because sometimes a context, all it's doing is just holding on to state that is global to your application. Because remember I said if you put use state inside the app, it's going to be local to that app component. And you have to pass a bunch of stuff down. I probably don't have to import React, honestly, on each component. It's just habit for me at this point. Yeah, I definitely believe it's not necessary, but I've been doing it for 6 or 7 years now. I'm probably not going to change. You should change if it's something that you find is useful, and you don't want to put in. Yeah, it's less typing, so definitely. I'm just too lazy to type less, I guess. Let's see, what is it? Oh yeah. So sometimes you just put state on a context so that state is just available to your whole application without needing to pass the property through. I feel like we call it like property punching or something like that. I forget what it was, but there was a term for like pushing a property through 30 layers just so it got somewhere, which is what we had to do before we got context. So we've got our map, right? This is not particularly useful to us, honestly, just having an empty array. So what we're going to do is I'm actually going to put a function on our value. And this is where context gets very powerful because you can pass functions into this, and set map is not something I'm going to expose to the rest of the program. But I am going to expose a function that lets the program tell the context how it wants to manipulate the map. So I'm going to actually pass an init map. Okay, and I want a width and a height. And that's going to be a function, okay? And that is available to app. So I can say init map equals use context map context. So now I have access to this function here because it's part of the value that's been passed into the provider. Whatever passes into this value is what I get out of use context. So I'm destructuring that object and pulling out init map. This is a very common thing you'll see in React, where that destructuring. That's why writing React or writing in a framework is very good for JavaScript practice because they force you to take advantage pretty much of all these different things in JavaScript. So init map. I want to call this when the program first launches because I want to start off my map with something. Okay, so if I just call init map, that won't do it because that renders every single time. And I'll show you if I put something in here and I say, okay, init the map. And I look at here, what is this thing? Oh, you can see it runs once. Okay, because the thing is only rendering once, but it will also run every single time the entire file re-renders. And so I don't necessarily want to do that. I want this to run once at the very beginning of my application and never again. The syntax for that is to call useEffect. UseEffect is basically a way of telling React, look, I want this code to run, but I don't want it to run every single time we re-render. I only want it to run when certain conditions are met. So useEffect takes two parameters. It takes a callback and a list of filters to look at. The callback is pretty simple, just standard callback. You put some code in here, like my init map, okay? The filters then is going to be an array. And what happens is every single time this function runs, every single time your program re-renders, which in React, it re-renders a lot. A standard React application will sometimes be re-rendering 10 times a second. It re-renders very fast, very often. It looks at this second parameter, all the variables that you put in here, and it checks. Hello, aware of existing, good to see you. It checks them against the last time they ran. And it says, the last time I ran this use effect, what was the value of these variables? And has that changed? And if it has changed, run it again. So this is very useful if you have, like, let's say I have someone's name, right? Right now we are working on kind of building a Wavefunction collapse, very simple version of it, to try to procedurally generate a map. For whatever purposes you might want to use a map for. Yeah, and we're doing it in React just so we can get some React practice in. We went over... Oh, okay, so yeah, we can talk about that a little bit. Again, a wave function collapse is basically a bunch of rules. So this is a little sample I put up. It's a bunch of rules about how to generate things. So we look at, like, mountains have to be next to forests. So if I try to put an ocean next to this mountain, I can't do that. I have to put the ocean next to a beach, for instance. So it's a little bit of a way, like if you totally procedurally generate a map and just absolutely give it random noise, it's going to give you something completely ridiculous. So this is a way to almost have random noise with a couple of rules on top of it. Yeah, and hopefully that becomes more apparent as we go along. But anyway, the use effect, whatever I put in here, like let's say I had, yeah, it might be a quantum thing. It's probably related to quantum. I watched a YouTube video about someone using this to generate a map for their video game, and I thought it was pretty cool. So I wanted to explore it today. But yeah, whatever you put in here, this will check and say, hey, is this different? So like if I put a name in here, this code would only run if the name changed. So if I put someone's age, this code will only run if their age changes. This value of this variable has to change in order to run this code again. So if you leave a blank array, it will only run once. Because the first time it runs this use effect, it will say, oh, cool. I am running this code. Let me remember the previous values that I was given in my second parameter or my second argument. And let me save those. And then the next time it runs, it says, oh, let me check those parameters against my previous run. Well, there weren't any. So there is never a case where a parameter can change ever again, so the function never runs again. And so if you want to have some code in your React app that only runs once when the component first loads, this is how you do it. You have use effect with your callback, and you pass an empty array as the second parameter. And if you do that, that function will run once and never again. Again, if you take that code and put it out here, it will run every single time the component re-renders, which is not what you want for most cases. So we've got that in there. Now we're initializing our map when the application first loads. And I can see init the map. I'm actually going to get rid of this thing component now because I think it served its purpose. And I don't really want to have it at this point. So what are we going to do when we initialize our map? We already determined that we're going to use a nested array for it. And the initialization, I kind of want to set the array and fill it with kind of garbage data. Or not garbage data, but like blank data, where it's like there's nothing there. So in order to do that, I'm going to declare a constant up here. Const empty. I'm just going to set it to 0. Why do I declare a constant here for empty and set it to 0? Well, because if I put 0 in my code, I may forget what that 0 is. So I might have something like map I and j equals 0. And then I have to remember what that 0 means. I have to think to myself, wait, why did I put that as 0? Does this mean that I'm emptying that map space, or does this mean that like there's nothing Like there's terrain, but no like trees, or what does that mean? But if I put empty, that's the same thing as 0, but it's much more clear what's happening in that code. Because I look at this code, I say, oh, I'm setting the map cell at I and j to empty. It's going to be an empty cell. And so 0 and doing stuff like that is what we call magic numbers or magic values. If you have something in your code where you've got let I is less than or equals 0, I is less than 6, I plus plus, etc. 6 is a magic value. What is 6? What does it mean here? I don't know. You know, hopefully I remember, or this is the sort of thing that I have to glean through the code and figure out, why am I looping over this 6 times? Why exactly 6? That's so weird. But if you have a constant up here that's like size of row and it's equal to 6, and then you're looping over size of row, that's much clearer. I say, oh, okay, basically this is a row. This is the maximum size. I'm looping over everything in that row. You might notice here there's a 0. That kind of doesn't count as a magic value because the I equals 0, it's so common we know what it means. We know that we're initializing our loop counter to 0 to indicate going on. If you wanted to define this as like 0 or start of loop, that actually might be more confusing to people reading the code because they're like, oh, the fact that they put a constant here means this doesn't start at 0? That's interesting. Maybe there's something more going on here, but if you leave it at 0, it's kind of more the expected thing and people know what it is. So basically you want to use constants when they reduce the amount of confusion in your code. For example, empty. So what I do actually want to do here is I want to loop over the full width. Well, it kind of depends on how the map wants to be, because if I'm doing a two-dimensional map like this, right, my width, I would say, is left to right, and height is up and down. And I'm just saying that because that's kind of how I learned to read grids. You might decide to look at it differently. That means that my rows are going to be based on width. They're going to be width wide. Whereas the number of rows I have is going to be height. So to start off, if I do something like map I j, first of all, the problem with that is I've got I and j. Is I the row or is I the column? I don't know, actually, because I'm just going with I. So instead, I'm going to call this row. Row plus plus. What is row going to be less than? Well, because the row, this is the specific row that we're on, not our place in the row. So that is actually going to be the height. And that's because if I have a row of 1 and I have a row of 2, that's the height. That's the number of rows. And that's what I'm looping over right now. So this is going to be row 1. Well, let me put actually like a little thing here. Row 0. And this is going to be row 1. So if I give a height of 2, I don't want it to be going further beyond that. And so that's why I'm saying row to height. Okay? So now I'm actually just going to say row data equals array. I would actually just call this row, but I was kind of dumb and I named my counter row. You know, sometimes naming things is hard. So now we're going to look at the column. Column is 0, and because we already used height, we're going to use width. Okay. So now we've got our row and our column. Row data dot push empty. So now at the end of this loop, by the end of line 20, I have a row that contains empty, or 0, the number of times I have in width. So then all I have to do is insert it into my actual map. Now, context and these set functions are supposed to be functional, which means you're not supposed to modify the state. You're supposed to set it, and you're supposed to use spread operators and a bunch of complicated stuff to make sure that you change it appropriately. That isn't always necessary. You can get away with it in a lot of cases, but I want you all to learn good habits, not bad habits from me. So what I'm going to do is I'm going to create a new map, And at the end of each row here, I'm going to push it onto my map. And at the very end of this function, I'm going to call setMap on new map. This creates an entirely brand new map, pushes all the empty rows onto it, and finally sets the map. And when you call setMap, that will trigger React to re-render. So what I'm going to do in here now is I'm going to go into app, and I'm actually going to pull out the map as well. And I'm going to print it. Assuming I can type it correctly. Now, if we take a look at that, oh, I did something wrong. I must have, because you see I get the empty array twice. So I must have screwed something up there. You know what it is? Init map takes in a width and a height, and I didn't give it a width and a height. And what it did, this is something that people both love and hate about JavaScript, okay? JavaScript said, well, you didn't pass these values, so they're null. The equivalent of null as an integer is 0. So at this point, they're saying, oh, row is 0. Row is less than height. And JavaScript said, no, 0 is not less than 0, so we're just not going to run this loop at all. And so sometimes you run into stuff like this. And this is where TypeScript can be really helpful. Because in TypeScript, you would actually say, hey, both of these parameters are required, and they're integers. So if I tried to call this like this, TypeScript would throw an error and say, yo, you got to give me the width and the height. Otherwise, we're not cool anymore. So I'm going to pass that in 5 and 5, width of 5, height of 5. Now, you can see we get, this is the first render of app.js. Because of the way Vite is, it doesn't have to reload the page completely. So that's why you see the previous logs in there. Kind of nice. This is the first one. This is our original map, empty, because we hadn't initialized it. As soon as I called that initialization, the whole component re-rendered and gave me this other map. All zeros, because they're empty, right? So let's do something else kind of a little interesting here. I want to actually build a specific method to set a cell. I want to set a specific cell on the map to a different constant. So I'm going to call set cell. This is going to take in an x and a y coordinate and a value. And it's going to be pretty simple. It's just going to set that particular place in the array to that value. So the true way of doing this is you want to spread operator on anything. What we could do is we could just say map x and, well, actually, y and x. I'll get into why that's reversed in a second. Value, and then set map. Except you'd actually have to spread it, because otherwise React doesn't realize it's a different object. This is bad. This is not how you're supposed to use this. You should never modify a state parameter like this. So what we should do instead is we should say set map, and we're going to spread map, okay? And then I think I can do this. I can say y, and then we're going to spread map of y, except the x is going to be equal to the value. It's not going to let me do that because it thinks I'm trying to do an object. You see the troubles we run into. So what do we have to do then? We have to create a new value, and we have to spread map over that value. Another problem we're running into now. We have now recreated map, but each of those inner arrays we did not recreate. We don't want to recreate all of them. So see, this is kind of when you start to get into the weird intricacies of React and how state works, and it's a little painful at this point. Because I want to do this functionally, and what functional means is that there's no side effects. You get data in, you pass out a brand new object out of this function. Well, or you call set map with a brand new object. And I shouldn't be modifying my initial map at all. Okay? So I'm going to say new row equals new map. I'm going to spread new map of y. I'm going to get that specific row, and I'm going to recreate it. The spread operator basically makes a complete new copy of this. Totally fine now, because we're dealing with brand new arrays. Then new row x equals value, and then I have to reset it. New map of y equals new row, and then I can call set map new map. Confusing? Yeah, a little bit. And again, you don't have to do this technically, but if you do it wrong, you will cause yourself a tremendous amount of pain in the future. Changing these state values, especially if they're nested objects, if you change them directly, that can actually cause ripple effects up through the rest of your program, which are using those old objects still. Until you call set state or set the set value on that new value, some other part of your program may just decide to run and do something else with that old value, and then you're screwed, and because you have no idea where that old value is coming from. So this is definitely the desired way to do it, simply because it contains that change. React can know when to do it. So what you do is you change your initial map and then you spread it into the set. So technically you are giving it a new object, but you're also changing the old one, and so it's kind of doubly weird. But yeah, if you just pass the old map back into the set, it's going to say, hey, there was no change. I don't need to re-render. Everything's hunky-dory. Because React is also very optimal with that. It's also trying to avoid re-renders whenever possible, because they're not expensive, but they do cost a little bit. Yeah, if you change map without setting anything, it won't work at all. And that's why we have to use the state in general. You could force a re-render. There are ways to tell React to force re-render, but those are extremely expensive because it doesn't know what you changed. So if you force React to re-render, it will re-render the entire application when maybe it didn't need to. So yeah, we do a little bit of work here, and this is a little complicated, but it makes the application more performant in general. So yeah, just again, we're spreading our map to create a clone of it. I want to change this row, so I'm spreading that particular row, modifying it, setting it back into new map, which again does not change the initial map or the original map rows. And then I set it. Now I'm going to come down here. Well, actually, let me do this. I want to export this constant, and I'm going to make a new one too. Export const mountain equals 1. Now I kind of want to, now that I create this map, I want to set cell, which should come out of here. And I want to set the cell at 22 to mountain. And you can see now this is the other reason that these constants are useful. If I just set this to 1, like you don't know what's going on here. You look at this, you set cell 221. Is this a 3-dimensional array that I'm setting this, or is this the value? What is 1? What does 1 mean? If this is mountain, then I know, okay, I'm setting this position to be a mountain. It's still 1 under the hood. JavaScript sees it as 1 and treats it as 1. This is not for JavaScript. This is for us. This is for people. Good software engineers write code that other humans can read, because anyone can really write code that machines can read. Machines are quite forgiving. Also, they don't really care that much about what any of this is doing. It's not that hard for them. So constants are useful for this as well. Okay. So now if I run this, I get a couple of things. Let me just rerun this whole thing. Oh boy. New map, why is not iteratable? Doesn't like that. Map context JS 27. Oh, you know why that happened? I called set cell before init map finished. So init map finished, but it hadn't actually, the set hadn't been processed, and then set cell comes in, does its thing. That's kind of problematic, because this is where the React use effect breaks down a little bit. I want this to run only once. I want it to run immediately after I initialize the map. Yeah. So something you can do, and this is something you can do here is I could have a use effect on the map, and I could actually put something in here like this, and I could put the map in here, and then I could put the set cell inside that. So I just typed a lot of code there. What this basically does is this sets up another event handler and says whenever the map changes, call set cell. And one of the issues with this is you'll see immediately, let's rerun this, we still get that same error. And the reason we get that same error is because every single effect runs once. Always. That's how this one works. But we get in here before the map actually has anything in it. So one good way of doing that, I'm actually going to start my map off as null. And then in here, I can say if map is not equal to null, then run this effect. And let me console log in here just to show you. Log map effect. Run this. Oh, lordy. We'll get to this, why this is happening in a minute. But you can see this happens a couple times. Now what happens, here's the fun part. This is why this doesn't work. I call set cell. That causes the map to change, which causes this to re-render. This effect goes off. I call set cell again. It causes the map to change. It causes the app to re-render, which calls set cell again. So that's a problem. One thing that you can do with this is instead of looking at the map, you have a flag on the context to indicate if the map is initialized. So I could set is set up. Oops, set up. And this starts off as false. Okay, so the map is not set up, and I pass this down in my value. Is set up. Now, as soon as I initialize the map, I set is set up to true. That's okay, because that render, these will be processed in the same render. In app, I actually listen to is set up, and then I only call this if is set up is true. The reason this works is set up will only change once. I call init map, and this is set up gets set. It's done. I only changed it once. And so this use effect technically only fires once, but it also only fires after the init function. It starts to get more complicated, right? So now if I take a look at this, everything looks okay. I'm not getting that error anymore, but I am still presumably setting this cell. So that's kind of a way that you can handle this. If you have some init and you need something to happen after the init, you set a flag on the context that only becomes true after the initialization. You can do this also if you're fetching data from an API. You set a flag on the context to be false, and then as soon as the API data comes back, you set it to true. Then you have an effect that does this. And it's listening. It's basically saying, hey, I want to know when you're done, because when you're done, I've got some stuff to do too. So that's kind of the way that I would go around this. The problem is it starts to get really complicated with this setup stuff, and then you may just want to pull your init inside the context so that it happens immediately. You could have your use effect in the context that handles that as well. So yeah, that's kind of the way of handling that particular thing. It's not amazing, but it is a common pattern. So now we've got our map initialized and we've got a cell set on it. Now we're actually going to display the map. And what I'm going to use is a table because I like tables. You can also use CSS grid to do a grid. You could do a bunch of other stuff. Tables have been around for 20, 30 years. They work quite well for what they're supposed to do. I think the backlash against tables in the last 5 years doesn't make any sense to me, but then again, I'm kind of old and crusty, so, But I'm going to put a table. Woo, table. Now, tables, you can put a table and just start putting rows in it, but you're actually supposed to use the tBody and thead property. That is so that the browser understands where your headers are, because it sometimes does stuff with those. It'll get a little miffed if you don't put a tBody. So then what we're going to do, we want to go through rows, right? Well, there's table row, but we want to make a dynamic amount of table rows based on how many rows we have in the map. And there's a very easy way to do that in JavaScript. And unfortunately, I did not realize that, or think through this naming, because now I have to call map on map. Not ideal. Row. So now we have map on map, and basically what is coming out of that is the row. Why are we using map and not for each? Well, because for each doesn't return anything as a result. we are basically taking this map, this array of arrays, and we're going to return an array of React elements that are going to get rendered instead. So here we are. We've got our table row. Okay. Actually, let me return table row. And then I'm just going to take a look at this. Complaining about keys. We'll get to that. Now, if I look inside this table, you can see I have 5 table rows. I have a row for every single map row. There's nothing in them yet, but we'll get to that. And what this does is this gives us the ability to say, okay, inside this particular little property, this is basically a loop. And this is why React kind of got popular with the ES6 stuff, is because before map and for each existed, you couldn't do something like this very cleanly. You had to actually create an array outside of the JSX and then push React elements into it and then put them in like that. This looks a lot better because it flows in with the JSX. So inside our table row, we're going to map over the row. And that's going to be our cell. Okay. There we go. So what I'm going to do is now I'm going to return a TD, and I'm just going to put the cell in there for now. Okay. So now we have a little bit of nice JSX in here that makes some table rows based on how many map rows we have. And then it goes through and creates a TD, or table cell, for each of our cells and tells us what's in that cell. So if I look at that now, there we go. There's our map. All these empties, and then we have that mountain in the middle. Pretty cool, right? We've got our map. It doesn't look that pretty, so let's fix that. I'm going to declare colors, okay? And I'm going to say the empty, well, yeah, let's pull an empty just to be good about it. That's going to be just white. The mountain is going to be a, let's make it like a light gray, like AAA. AAA is a good one, okay? So now I come down here to this TD, and I'm going to set a style property on it. And I'm going to say, well, the background color is going to be equal to, what is an object? Colors indexed by the cell. There we go. Now it's gray. Still not super impressive. Let's take the cell out of that and see what happens, because I don't want those numbers. Well, now it's just blank. And you can see that one tiny little, there's a 2-pixel gray there in the middle. Let me zoom in a bunch. Oops, that is not the thing I wanted to zoom in. Zoom in here. You can see that tiny little gray pixel there. So what I want to do is make it a little bit bigger. So let's add a width of 25 and a height of 25. That looks better. That looks a lot better. Okay. And now if I put, like you notice they're not quite up against each other. That's because of the table padding, the table spacing. I'm going to leave that alone for now just because I don't remember off the top of my head how to actually change it. If it becomes problematic, we can get back to it. But it's kind of nice to have a little bit of spacing in between them too. Okay. So now, let's say we have our cell here, and we need to perform our wavefront collapse, or wave function collapse on top of it. That means we basically need to go through every single cell and determine what they could possibly be based on our starting cell here. So let's see how we want to do that. I want to have this be a process I can kind of control step by step. Okay, I want to be able to say, give me the next step, right? Give me the next step of this wavefront collapse. Let's do that. So I'm going to put a button on here. Button, okay, and I'm going to call it take step. Button. Doesn't do anything right now. Also, we should take care of this key. Each child in the list should have a unique key prop. Why does React do that? It's very annoying. Well, the thing is, sometimes if you're dealing with React things, maybe I just deleted this row. In that case, React shouldn't re-render the whole table. It should just shift these rows up and delete just that one, right? And so what that means is React is trying to be efficient. React doesn't want to render more than it should. In fact, most of the time your application is re-rendering. React is not actually re-rendering all of it. It's running through all your components, and then it's using its shadow DOM. And it's saying, okay, let me compare the changes of what changed from the last time I rendered this. And it only makes those changes. So if I only told it delete row 2 here, it would say, oh, I only have to delete the second row. Problem is, when you start getting into arrays, React starts getting confused because it doesn't have a good way to determine if the array actually changed. It knows that something disappeared from the array, but what disappeared? And that's where the key comes into play. If each one of these has a key, then React remembers, oh, the last time this happened, I had key 0, 1, 2, 3, 4. Now I only have key 0, 2, 3, 4, which means that this row must have disappeared. So it knows more specifically which change it can make in the DOM. If you don't give it that key, it will actually just re-render the whole table, which can be kind of expensive. So what we're going to do in here, it's very easy to do this. You take the top level component that's being returned from your map, and you put a key property on it. Now, what they say in React, it's a bad practice to use your index as the key, but I don't have anything else really to go off of right now. And so I'm just going to say this is row index. Notice that does not show up here at all. Now React complains, hey, each child in the list should have a unique key prop in the TR. It's complaining about the TDs now. For the same reason, it wants to be able to optimize those re-renders as they come around. So I'm going to do the same thing here. I'm going to say key equals, well, let's actually do this. Call index. Key equals column, and then I'm going to put the row index in here. And then I'm going to put the call index. The thing is, you want your keys to be unique. React will get very grumpy if your keys aren't unique, because that confuses the hell out of it. If you have non-unique keys, it's like, well, I don't know what to do at all now. I'm just real confused. So I've made sure this is unique because I've got that index in here and the column index, which are guaranteed to be unique for this map. If I had multiple maps, I'd probably put an ID on them as well, of like map 3 row index 2, sort of stuff like that. And now if I rerun this, oh god, cannot read previous null reading map 29. Row index, what does it not like about that? Cannot read properties of null reading map. Somehow it got this row screwed up. It doesn't like, oh, you know why? Because I think because I double, no, that should be fine. What does it not like about that? I don't like something. Key, I got the key, that's fine. That's okay, that looks all right. Map is empty. Oh, that's true. That's a good point. Because map is null when it starts out. Yeah, very good point. Okay, well then we're just going to do the equivalent of a React if statement. Map and table. And just say, hey, don't render the table, unless you have a map object. It's a good catch, Isaiah. All right, there we go. Let's reload that. No more warnings, no more errors. Very cool. Okay, take step. Doesn't do anything right now. Let's make it do something. What I'm going to do now is I'm actually going to put... I'm going to put the Wavefunction collapse inside the map context. It could be a utility class that's pulled out that just acts on the map context. Actually, no, maybe let's do that because that'll be interesting as well. I'm going to make another directory called utils. And utils, I like to use the utils function for stuff that basically it's code that is kind of disconnected from the actual application I'm building. Like it's not really, doesn't have to be part of this application. or it's something that I want to be able to use in multiple places, right? And so in here, I'm going to call use collapse. Why am I calling it use collapse? Because I'm planning on writing a hook. We've had use state, we've had use effect, we've had use context. Those are all hooks. They all start with the word use. That is not, there's not a law that says that every function that starts with the use has to be a hook, but it's a convention. And conventions are sometimes more powerful than laws. The reason is you declare a hook most often when you want a function that can utilize other hooks. So in this case, the reason I'm doing this is because I want to be able to do my collapse function stepwise. I want to be able to click a button and then have it do something and pause while I see what it did, and then click the button again and have it continue, which means I need to be able to store the state of where I am in the process and freeze that state, which means I need to be able to call use state, which means I need a hook. I can't just have a random function and be like, function, foo, and then like, blah equals use state, and then do some stuff. I can't do that. That's not how React works really well. It technically, like, it will work kind of with this, but it doesn't work the right way, in the way that you'd think it should. So what I want is I want to export default function use collapse, because again, I'm making a hook, okay? And then I want to actually have a current x, and I'm going to call use state and set it to 0 for now. And then I want a current y. And what I'm going to do inside this function is every time I run a specific cell, I'm going to remember my current x and current y. And then I'm going to, the next time this use collapse is called, I'm going to have the values of where I was already. Okay. The other thing that's very convention for things like this is if you return a function. So I'm going to return a function. Okay. And this function, the collapse, is actually going to perform the action that I want, because I don't want to do an action every time I call use collapse, and I'll show you why. If I put this in here, okay, and I just call use collapse in my app, say, okay, let's just call use collapse. Let's look at how that renders. Whoops, what did it not like? Use collapse is not defined. That makes sense because I didn't import it. Use collapse. There we go. All right, you can see that ran 3 times. It ran 3 times and I haven't even clicked the button yet. So if I, basically because hooks are supposed to run every time the component re-renders. That's how they work. That's how they operate. But I don't want the business logic of this collapse function to run every time I re-render. I only want it to run when I click the button. And so that's why it's very common to have these return a function. Because if I have this as a function, because of the closure of JavaScript, this function has access to current x and current y, and it can set them as well. But you notice now if I re-render this, it doesn't say do the collapse at all. And now inside my button here, I can put that as the click handler. So now it only runs the do collapse when I click the button. So that's a very common way of building a React hook, is you set up the use and it returns a function that you call whenever you want to actually take the action. You may call it immediately, but it's just very common. Like, you don't normally do the business logic inside the body of your hook. You do it inside the returned function. So what I also want to do is I want to have a start x and start y, because I don't want to just start from 0. Well, actually, no, maybe let's start from 0. Let's see what happens, okay? So now, our wave function, we need a couple of things. We need a couple of rules, right? And let's declare our rules up here. I'm not actually going to export these because I don't need to utilize these outside of this file. So I'm not going to bother to export it. And the way that I'm going to do these rules is I'm going to have them work like cell type goes to list of cell type, cell type. And so what that's going to indicate is this cell can have these two cells as neighbors. Okay. And so that means I got to import mountain and empty from the map context because those are our cell types. So let's see, what can the empty have? The empty as a neighbor can have anything. The empty type doesn't care, technically. It's empty. It can have any neighbors. It doesn't really have rules, but we kind of have to define it this way. The mountain type, well, right now, the only thing it can have next to it is a mountain. We don't want the mountain type to have an empty neighbor. We're not really okay with that because as soon as we are trying to do a cell, we don't want to stay empty. We want it to be filled with something. So I'm going to say the empty can be mountain, but the mountain cannot be empty, cannot be next to empty. This is like kind of a neighbor relationship. We're saying at any point in our graph, it is okay for an empty cell to have a mountain cell as a neighbor. But as we're processing our map, it is never okay for a mountain cell to have an empty cell. We don't like that. And I'll hopefully try to explain why it'll work that way. But basically what we need now is we also need the map. All right, so we're going to, well, here's the thing. I could get the map, or I can make a helper function to get cells out of the map. And the helper function is kind of, I kind of like that a little bit more. So I'm going to make get cell xy. And this is going to be pretty simple. This is just going to return map y of x. The reason I have the y first is because this map is rows. And so the array is kind of on its side for the initial array, and then it goes out. Let me know if that confuses you. But basically, it's because the row is first and then the column. And that's why I did it that way. This is very simple, but it may become more complicated. And this is kind of why it's useful to build helper methods like this. If you put a bunch of places in your code that use the map and use this y and x, and you decide to change the way your map works, you have to find every place in that code and you have to rewrite them to work that new way. On the other hand, if you just have a nice get cell method, I can completely rewrite the map as it works under the hood right now. And nothing would really need to change except that app, because the app shows the map. But everything else would just be using get cell and set cell, and so their interface wouldn't change. So building interfaces like this can be really powerful because it allows you, it kind of decouples your underlying implementation from what actually gets provided to the rest of the program. So I'm going to pull in get cell and set cell context, map context. I can do that because this is a hook. Hooks can use context. Use context is just another hook. So my collapse here, I can call that from in here, collapse, and it already knows everything about the map. I don't have to pass the map into it. It just knows the map. It knows everything about that and everything of how to manipulate it, which means that the abstraction logic of how the collapse works can be worked on in one file and hidden from the rest of the program, which is very helpful because the app doesn't actually care what collapse is doing. It just knows it needs to call collapse, and it knows how to generate the map. In fact, this map code is a little too coupled with the map context, and I kind of want to do some stuff to change that as well. Not the biggest deal, though. So now instead of use collapse, first thing we need to do is we need to figure out what cell we're working with, right? Okay, what is our current cell? Well, our current cell hopefully should be empty, but let's just see. Const current cell equals get cell current x, current y. Okay. Now, basically, if our current cell is not empty, we're going to skip it. If current cell is not equal to empty, we're just going to return. Okay. We're not dealing with it. We're not dealing with a non-empty cell. It's already been processed by the algorithm, or the users set it themselves, which means we definitely don't want to mess with it. We only want to work with empty cells. So now that we have an empty cell, we need to get all of its neighbors, because we need to find out what it is allowed to become. If all the cell's neighbors are empty, well, it's allowed to become a mountain. If all the cell's neighbors are mountains, then it's only allowed to become a mountain. That will become more interesting the more cell types we add. Okay. And that's kind of where the complexity arises. So let's see here. First of all, I'm just going to make, because I don't really care necessarily where the neighbors are. I just care that they are neighbors. Okay. So I'm going to look at, there's a couple ways of doing this with neighbors. The cleverest way is to do an array of offsets of your current position, and then you loop through that offset array and build up new indexes, but that's also kind of confusing. So what I'm going to say is I'm just going to do this, dot push, let's do it manually, get cell, current x minus 1, current y, and then I'm just going to copy this 4 times. And this is going to be current y minus 1. This is going to be current x plus 1. And then this is going to be current y plus 1. I only need 4 because I'm only doing orthogonal. I'm not doing diagonal. If I needed the diagonal, I'd have to do 8. So now we've got all the neighbors of our cell. And I'm just going to console log them. Because that's a useful thing to do, right? We want to make sure our algorithm's doing the appropriate thing. Missing initializer and destruction declaration. What? That's not the code that's there anymore. I think V got stuck. There we go. Sometimes that happens. So if I click take step, it will now attempt to process this top cell up here by looking at its neighbors and determining what it can be. And it crashed. That's interesting. Cannot read properties of undefined, reading 0 here. Map y of x. That's interesting. That's quite interesting. So what did we get wrong here? Well, let's check and see what we were at, what coordinates we were actually trying to put in there. X, y. Oh, and let's just put the map for good measure. This is shotgun debugging. Or not shotgun debugging, console log debugging. If you know how to use the Chrome debugger and are comfortable using it, use that by all means. I am just more comfortable with console logs. All right, let's reload that. Take step. Okay, so 0, 0, 5. Oh, now that's interesting. This worked okay. This one worked okay. That one worked okay. It's just we got here. So that last console log, that was the problem. That was the problem one. That's 0, -1. So why is -1 there? And the reason is obviously because our map can't index into negative numbers. That's not a thing we can do. So this is why having get cell is useful, because I can say if x is less than 0 or y is less than 0, return empty. We know it's just going to be empty then, right? It's off the map. And that's why if I'm using get cell, now I can put these guards, and any place using this function automatically gets the protection of that guard. Otherwise, I'd have to go through and add these guards to every other place I'm calling the map. So this is, again, if you start early by building these utility methods and helper methods, then if you need to modify them, it makes it a lot easier. So let's reload that again. Take step. Okay. There's our neighbors. All 4 of our neighbors are empty. Which makes sense, right? They are all empty. All of our neighbors should be empty because there's nothing there. There's nothing here, there's nothing here, there's nothing here, and anything off the screen is empty. So what I want to do now that we have our neighbors, I want to build a list of what tiles we're allowed to have for those neighbors. So I'm going to say allowed tiles, or allowed cell types. It's here. This is actually, let's just make this a set because sets are cool. We've got a set. We're allowed to be those tiles. The reason I want to do a set is because if I've got mountain twice, I don't want to insert it twice in the array. I only want it to be in there once, right? I only want to have a set of unique tiles that I can turn into. Again, if anyone has questions on anything I'm doing, please put them in chat. I am occasionally glancing at it. So then I'm going to loop over my neighbors. I have been doing too much PHP. Neighbors. This is not a coordinate pair at this point. This is actually just a type. So I can index it against my rules here. and I can say, okay, new allowed types equals rules neighbor. And that will give me the allowed types that that neighbor is allowed to be. Because I don't want to have a type where my neighbor is not allowed, is like, I don't want to be next to that tile. I don't even want to have it. You have zero idea what's happening. Well, I am really sorry about that. Let me know if there's anything I can do to help explain this a little clearer. I have been told that I go too quickly, and that I kind of make logical leaps that aren't clear to other people. So yeah, I can slow down potentially. But yeah, I'm basically building an algorithm to figure out what tiles I'm allowed to place based on what my neighbors are. So let's say for an example of like, let's say you have a neighbor in like an actual house, and your neighbor, because you live in a housing associations are absolutely terrible. As someone who lives in one, I know this. Let's say your neighbor has a dog, which means by housing association rules, you are not allowed to have a cat. It's important that we know those rules because we don't want to put a cat next to a dog. That'd be bad. And so that's what these rules are basically saying, the only things that are allowed to be next to them. So a mountain right now can only be next to another mountain. And again, well, maybe if I add a third one in here, I'm going to add a forest. Let's add our forest in, okay? We're actually going to add that in here as well as a color so we can display it. And I'm going to make that like kind of a greenish. Not settings. So now empty can have forest next to it. Mountains can also have forests next to them. Forests can be next to mountain and forest as well. So if I have a tile that's a mountain, it can, and I'm trying to figure out what its neighbor can be. Its neighbor can be a mountain or a forest. If I've got a forest, it's got the same thing. It could be a mountain or a forest. Neither of them wants to be next to an empty tile. They don't like empty tiles. So if I'm trying to place a tile and it's got a mountain next to it, I know I can't make it an empty tile. The mountain is not comfortable being next to an empty tile. It'll only be comfortable being next to a forest or a mountain. So that's what I'm trying to figure out here. And then, let's see, is there a way to append an array to a set? So I just looked up append array to set JS. The JS is important so that Google knows what language you're actually asking. I could ask ChatGPT too, but that's not part of my daily repertoire yet. Stack Overflow, how to add an array of values to a set. Sounds great. Let's look. For the sake of this example, manage the set was created somewhere else. I cannot construct a new one. How do I add? This is what they're doing. Is there a more elegant way of doing this? Set API is too minimalistic. You can use for each. So basically, no. There's no way of doing it. There's apparently a stage 1 proposal. Add all. When the add all method is added, it adds all the elements into the set. A proposal means it is not in JavaScript yet. This does not exist in JavaScript yet. At least not at the time of this question being asked. And how that was in 2018 though. So what we could do is let's just look up JavaScript set add all. And let's see if the Mozilla documents talk about add all. Prototype add, it doesn't look like it. So if this is a stage 1 proposal, it hasn't made it into the language yet. Nice to know they're thinking about it though. So basically the only way we can do is another for loop of new allowed types, and we'll just do a for loop here, and then allowed types.add item. Because this is a set, it is going to remove duplicates. So if I've got something that's surrounded by an empty, a mountain, and a forest, it's not going to add mountain 3 times. It's only going to put in once because that's the property of a set. This is only going to have the item once. So now at the end of this, let's just console log our allowed cell types. Okay. Okay, and we're getting errors. Great. Forest is not defined. Oh no. We better define forest. There we go. Okay. Take a step. I've got 2 items in my set. 1 and 2, mountain and forest. Totally cool. Very cool. Can I index a set? Can I like grab the 0th or 1th index? I don't think that's a thing that sets actually have. They don't have like indexability. So I need to convert it to an array. Because what I want to do now that I know what tiles I can do that are valid for this part, I want to randomly select one of them. Okay? Because I don't care which one it is. I know they're both completely legal to put in this spot, so I'm just going to pick one at random. So let me see. This is something that I've actually done quite a lot. JavaScript generate random number between 2 numbers. I go to Stack Overflow, and I cannot tell you the specific number of times I have copied this exact code. Because this person, as you can see, many thousands of people have thought that this was very good code. It works perfectly. I'm going to put that into another util, random.js, and I'm going to put in here, and I'm going to export it. Why did I put it into a different file? It doesn't belong in useCollapse. It's a randomization function. You want to separate the functions out into collections of things that they are similar to. Random.js, I know, should contain random methods. So if I have another random method, it should go in here too. It does not belong in useCollapse because useCollapse might not be the only place that wants to know about random numbers. The other most important thing is attribution. Not technically required, but what I do is I copy this link down here, and then I'm just going to put it in here, right? Because then if someone is interested, where did I get this code from? They can click on that link and they can see the person that actually did it. Stack Overflow has some interesting ideas about code copying. And I have been at companies that have been like, don't copy from Stack Overflow. And then they change their mind after every single developer revolted. But yeah, it's just nice to give attribution because I didn't come up with this. I could have, if I took a couple minutes, but it's much simpler for me to just grab this code. So that's the thing. If you are going to take a function from someone on Stack Overflow or a blog or something, just put a little comment saying where you got it from. It's just polite. Even if they're not asking you to give attribution, it's just nice to say, hey, this isn't technically my code. It worked really well. If you like it, here's where I got it from. And it's just a kind thing to do. So what I want to do then is I want to import that. Import, oh, I should have export const actually, because I may put more random stuff in here. Or export function. I don't want to export default because this might not be the default. From, we're already in utils random. So now I've got my random int. I want to get a random cell type out of my cell types. So random cell index equals random from interval, 0 being the min, the max being allowed cell types dot length. Again, very common thing if you have an array and you're trying to get a random element of that array, random int from interval, 0 to the length, because the length is exclusive. Oops, and let me just look at my random cell index, and I'm going to console log that as well. Then come in here, run this, take a step. It gave me not a number. That's not ideal. I must have fucked something up. Min and max. Oh, min and max are included. That's interesting. Then in that case, I want to have this be -1 because I don't want that end one to be included. Also not completely sure why that's giving me not a number. This is basically going to be random times min minus max times 1, because I have 0 and 1. It's going to be out of 2 plus min. Well, let's see if it happens again. Still giving me not a number. Random cell index, random int from interval. Okay, well now I guess we debug it a little bit. Let's just take a look at this before we put it into the floor. do console log min, max, and oh, you know what I bet it is? The length. There's no way to get a length off of a set. I bet that's the problem. And there you go. Both, yep, the max is not a number. Okay, so there's nothing wrong with the function, which is good because I use it in a lot of places, but allowed cell types.length doesn't exist because it's a set. We need to turn this into an array. So, JavaScript set to array. How to convert set to array? Array.from. Well, that looks perfectly fine. Let's just do that. Allowed cell types list equals array.from allowed cell types. And then here, I'm just going to, I'm just going to replace that variable down here and down here. So now we're working with an array, which we know we can deal with a little bit better. Now we get 0, 1, 1, 0, 1, 1, 0, 1. Random, right? It picks a random number. So that's working. So now at this point, we have a random cell. And in fact, I'm going to say random cell equals allowed cell types list random cell index. Here are those console logs. Now we have the random cell. We know this cell is randomly chosen out of all the allowed cells based on our neighbors. So now all we have to do is set it. So we're going to call set cell. This is going to be current x, because that's the cell we're working on. Current y, random cell. I'm actually going to change this to random cell type, because a random cell might more indicate like the actual coordinates of the cell, whereas this is the type. So, oh look, it turned into a forest. What if I take another step? Nothing. Nothing. Nothing happened. Well, that's kind of weird, isn't it? Why is nothing else happening? Well, the issue is we're not advancing our cell. We're not advancing our current, right? We've done this cell. We need to move on to the next cell. But every time I rerun, it's just looking at current x and current y again. And it's not empty, so we're just skipping it. We're making... Oh, yeah, there you go. Chat can answer that question. That's okay. It's all right to be late. I do not mind the questions. I want to make sure that y'all are understanding what I'm doing. But yeah, basically we're trying to generate a procedurally generated map by using various rules of what is allowed to go next to various cells. Okay, so let's say I come down here, current x, current y. At the end of this, I actually want to advance my current x, right? I want to move along. So I'm going to say set current x plus 1. All right, let's try that. Okay, forest, mountain, mountain, forest, and it destroys itself. New allowed types is not iterable. It's not iterable. New allowed types. Okay, well, let's take a look at that. New allowed types is not iterable. What that tells me is the neighbor was invalid, because that's right here, right? That means this is null. How could that be null? What that means is the neighbor didn't exist. And I'm pretty sure what happened there is I'm working on this cell. I've got guards against going off the edge here and off the edge here. I have no guards going off the edge this direction. So I probably actually got null passed in. And so one of these neighbors is probably null. And if the neighbor is null, then obviously we have no rules of how to process that neighbor, because we should never get null. So that means we come back to our map context, and we want to do the same thing, but with the width and the height of the map. Only problem, though, we don't know what the width and the height are. We could get the 1 by looking at the size of the map. I guess that could work. So we could say if x is... Well, let's try y first. Is y is greater than map.length, well, then we're going to return empty. All right. Or, now getting the width is a little harder, because the width is actually of the row that's nested. So, or x is greater than map of 0, because we have to get one of those rows, dot length. If our map has nothing at all, well, then hopefully we caught that here. Let's try that again. Step, step, step. The console step. Nope, still issue. Reason is map.length is going to be 5, but the actual largest indexable element is 4. So y, if y is going to be, the maximum y we want to allow here is actually going to be 4. So it needs to be -1. Just a thing to keep in mind, and this will become very intuitive for you eventually when you're dealing with arrays or lists, and you're dealing with stuff like this. The length, most often, if you're doing coordinates, you put a -1 in it just because you have to. And the reason for that, I'll do a little bit more. Let's say we have our array 0, 1, 1, 2, and I try to access index 4. Well, arrays are 0 indexed, which means I'm actually accessing index 3. That's this one. So this is 0, 1, 2, 3. That's kind of confusing. Let me just change these numbers a bit. The length of this array is 4. So if I say, hey, is 3 greater than the length? That would be, is 3 greater than 4? No, it's not. You're totally cool. I'll be like, all right, great. Is 4 greater than 4? 4 is off the end of this array. We should not allow 4. So this says, no, 4 is not greater than 4. You're fine. But if I say the -1, I say, is 4 greater than 4 minus 1? And it goes, yeah, 4 is not cool. 4 is off the end of the array. So that's the simple reason why we need that -1 in there, is just because the length is going to be the actual number of elements, but because they're 0 indexed, we can't go all the way to the length. We cannot go all the way to the length -1. Hopefully that is clear enough. If not, let me know. Maybe I'll do a video on it. All right, let's try that again. Step, 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 step. Hey, step. Step? Uh-oh. What's going on? What is this step? Where are these coming from? We've now got a row. This row only has 5. And this row has a ton. How did that happen? Well, JavaScript is being nice to us and it's saying, oh, you're trying to set a position, right? Because of the way that we added our set cell, we're trying to set a position here that doesn't exist yet. So it just says, oh, I'm just going to create that for you. Because remember, JavaScript arrays are actually linked lists, or technically actually hash maps, but they behave like linked lists. They're like, yeah, I don't care about my width. I can set that. So what I kind of want here is in use collapse, as soon as I get to the end of my row, I kind of want to go to the next row, right? I don't want to keep going on one row forever. I want to move down to the next row and keep going, which means I need to know the width of the map here. Because I can say if current x plus 1 is above map width, well then I'm going to reset current x to 0 and increment the y instead. But I don't know what map width is. I got it here though. Right, here's my map width. It's map 0 length -1. So I'm just going to make a little method for that. Get width. And I'm just going to return this. I also might be able to put something special and say if map.length equals 0, well then we're just going to return 0, because if there's no rows, then clearly there's no width. Okay. And then I'm going to come back here. Get width. So then I can say if current.x is greater than the width of the map, then I'm going to actually set current x to 0 and set current y to +1. Otherwise, I'm just going to increment my x. A little bit more complicated here, but now I'm just saying when I get to the end of the map, go to the next row, back to the beginning. Kind of like, well, you guys are probably too old for, or too young for typewriters. But that's basically how a typewriter carriage return works. So now let's see. Step, 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 step. Went down to the next row. Step, 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 step. Why isn't it going further? Well, here's the problem. We're on this square right now. This square already has something filled in because that's where we put our initial thing, right? All of this set stuff doesn't happen in this case. If the current cell is not empty, we just return. We never actually increment at all. So what I'm going to do is I'm actually going to pull this out because the thing is, I could actually just duplicate this whole block of code and put it in here. Say, oh yeah, if the current cell's empty, just skip ahead, increment. That's kind of a lot of code. I don't like the fact that that's duplicated in 2 places. What if I have to change it? I've run into so many bugs where I've forgotten to change something in one place, but I've changed it in others. So I'm going to make a little function here. Const move to next cell. Just going to put this in here. And then here I'm going to call move to next cell. Copy that, and I'm going to replace this code with it down there. Now, not only is it clear in my code what I'm doing, move to next cell. We know what that does. If I change this code, I only have to change it in one place. Definitely always a good thing if you have complicated code that you need to do more than once, function. The general rule is if you use code more than twice, you should put it in a function. And as you can see, JavaScript makes that really easy. This is a little function that's just in scope for use collapse. Doesn't have to be anywhere else. I could even put it in use scope inside here, but it just didn't feel as right. Okay, so now let's see what we get. Step, 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 step. And now it moves on. Step, 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 step. Uh-oh. Well, now when we get to the end here, we go off the deep end of the height. Well, we can't go any more steps anymore, right? But now you can see that's kind of a cool random biome, right? Let's try that again. Bam. Whole other new random biome. Let's add in a beach. Okay, and the rule with the beach, remember, is the beach can only be next to a forest. Yeah, it's mini Minecraft, basically. And in fact, Minecraft may use something similar to this. I'm not completely sure. So let's define a beach. Beach equals 3. Okay. We need to determine how to draw the beach. So we put it in here, and we say, okay, beach is going to be kind of a yellow, right? What is yellow? Yellow is between green and red, right? So if I say FF0, that should work. I think yellow is between green and red. We'll find out. Now inside my collapse, I have to import it. And I don't need to write any more logic. All the logic's there. What is it? You know, I don't know. I don't know these things. So now I have to determine not only what a beach can become, but what is okay with being next to a beach. Empty is okay with being next to a beach. Mountain is not okay being next to a beach. Forest is okay being next to a beach. What is a beach okay with being next to? Well, beach is okay with being next to a beach. It's also okay with being next to a forest. So now that we've added that into our rules, right? So empty can be next to a beach. Mountain cannot be next to a beach. Forest can be next to a beach. Beach can be next to a beach or forest. What do we get now? Okay, mountain. Well, we weren't supposed to get a beach there. Something's very wrong with that. That's not good. You know why that's happening, though? Because we're doing the inclusivity of this. We're saying, so that is a problem with our algorithm. The empty can be next to any of these. So then we say, oh, mountain, you could be next to mountain or forest. So we just merge that. What we need to do is we need to say, okay, what's the most minimal set? We basically need to say, okay, if we go through empty and mountain, does beach appear in both of those? So what we really need is the intersection of these arrays. We don't need the ORing of them. We don't need them pushed together and said, give me everything that's unique between these. We need the intersection. So that means this needs to change a little bit. what we need to say is, okay, new allowed types. We have our existing allowed cell types, okay? So the first thing we want to do here is if our set is empty, let's do this. We want to start off our first set with the rules of our first neighbor, okay? Because now what I want to do is I want to kind of, sorry, I'm doing a terrible job of explaining this. Let me write out some little pseudocode or code here. Like, let's say I have mountain, forest, beach, and then I have mountain, forest. I want to know what elements exist in both of these arrays. What I was doing before is I was saying what elements exist in any of these arrays. So I was getting MFB because the B exists in both, or one, F exists in both, M exists in both. What I want instead is I want to say what are elements that only exist in all of these. Okay, so I only want the M and the F in that case. If you don't understand why that is the problem, just say something in the comments and I'll explain a little bit better. But yeah, that's how we ended up with a beach next to a mountain, even though that is not supposed to be there. Also, that is yellow. Okay, I got it right. So instead of this new allowed types, and we're basically adding it to a set, which gets the uniqueness, instead we want to know the ones that kind of what I want to do here is I want to set this set to the first neighbor. Every neighbor that comes after, we're going to compare the two. And we're going to say, what is the intersection of these two? In fact, does JavaScript have a way to intersect arrays? Array intersection. That would be nice because then I don't have to write it myself. Okay, array intersection difference in union ES6. Sets, code, etc. Yeah, so this is what we're looking for. We're not looking for the overall, we're looking for the intersection. Intersection, oh, okay. So here's the way to get the intersection between two sets. I'm just going to steal that code. I'm going to put that in here. This then is going to be an array, okay? I'm going to spread the first neighbor. So I'm going to say first neighbor allowed equals this. Neighbors, I cannot spell. 0. The reason I'm doing that is because we have to start with something. If I take the intersection of an empty array and anything, it's going to be the empty array. First neighbor allowed, and then we're going to say, I'm actually just going to do a let on this because I'm going to redo it. Equals, and let's do this filter. First neighbor allowed dot filter rules neighbor includes. That's a little complicated. So I'm actually going to make this a little bit easier to read. Return, because I don't like that syntax. Let's pull this out. Let's say new neighbor allowed. And this actually needs to be allowed cell types here, I'm realizing. What's that? Okay, so what we're doing here, we're getting the cells that are allowed by our first neighbor. And we're putting that into a list. Then, every time we go over a neighbor, we're saying, okay, well, what does this neighbor allow us to do? And we're getting the intersection of those two arrays. So if we have a neighbor now that allows beaches, but the other neighbor doesn't, we're not going to get beaches. They're going to get filtered out of here. And, you know, I could go into a little bit of detail of why this works for an intersection, but I'm just going to trust the blog person. I know it works, so I'm just going to trust them on it. Let's try it now. If you want a deeper explanation of that, please just let me know. Okay, we got forest, we got forest, we got forest, we got a beach. We got a beach. Okay, we got forest, forest, mountain, forest, forest, a lot of forest. We got beach, forest, mountain, mountain, beach, forest, mountain, forest, mountain, Okay. Little bit more variety, right? A little bit more. I like it. I like it. So now we've got 3 types, and you can see none of these are violating those rules. The mountain is only touching the forest is touching the beach and the beach can never touch the mountain. I need a reset button. That is really what I need. Let's just take a couple of these steps. Cool, more beach this time. Now let's bring in our ocean. This is the last tile that we're going to do. Ocean 4. Okay. Again, remember those constants making things useful here because now we know what we're dealing with. We're never having to deal with the number 4. We're just dealing with a constant. Ocean. This is going to be a blue, which is 00F. And then let's look in our collapse. Well, we know the empty can become an ocean. The mountain cannot become an ocean. A forest cannot become an ocean. A beach is perfectly fine being next to an ocean. What can an ocean be next to? Well, ocean is comfortable being next to an ocean and a beach. Let's see what we get now. Okay, beach, forest. Still not seeing any ocean. I didn't see any ocean. This could have been an ocean, but I guess the random number generator didn't show up the right way. Oh, there we go. There's some ocean. Oh, this will be interesting. When we get to this square, what will it do? It collapsed. It doesn't know what to put here because there is nothing that we have that can go directly between a mountain and a beach or in an ocean. So that's kind of interesting, huh? What do we do in that situation? Well, technically, this is a problem with the rules. We shouldn't allow the system to get into a place where it doesn't know what to put. So what is in between an ocean and a mountain? What is the transition between that? It's not really a beach, right? And that's why it exploded, by the way. First neighbor allowed is not iteratable on line here. Because, well, actually, why did that happen? What I'm going to do is I'm going to set this scenario up again. What I'm going to do, let's set cell 2 to a mountain, and then this one was 2 0 to an ocean. You see what happened there? We tried to do mountain and it overwrote with an ocean. This is a problem with React. Flatland, grass biome. Yeah, maybe grass biome. That might be a good idea. I tried to set a mountain and an ocean. I only got the ocean. Why did that happen? Well, when I called set cell, here's the issue. Set map and map. Map, I called set map, but remember, I didn't change the map. I just called set map, and this is not updated. This component is not re-rendered, which means map is still the old map. So let me just console log it to show you. We'll console log the map, go in here. So here's the first set, right? I set this one to be 2. Here's the second set. It ain't 2. I need to get the most up-to-date map from the state so that I can set the new data on it. Now here's how you do that. Okay? The set can take a callback in addition to this. So if I call set map like this, the first argument will be the current value of the state, regardless of what is here. Because remember, this is dealing with the closure of JavaScript. This object will not update when I call set map, because that closure is still holding on to the old value that I didn't modify. Passing a function into set map means that it will pull up the most recent value of the state. And so I can take all of this and put it in here. And this just needs to be current map, and I just need to return new map. And so that's the way if you have if you know that you've changed your state, but you need to change it again before the next re-render, you can use this callback function to get the current value of the state as it is without paying attention to the closure value, which may not have updated. So that's just a thing you can do in JavaScript. And now you can see now we have both. So now we get here and I want to see it skipped over that. I clicked that and it skipped it. And then we got to here. This one got skipped. I had to click it again. When it got to here, it checked all three of these and couldn't find something. And that's weird to me. First labor allowed is not iteratable. That I don't understand. Why is that happening? And I want to actually... Let's console log neighbors. Okay, let's take a look at our neighbors right now. Oh boy. Okay, so we go here. Okay, so now the next click is going to be this cell. I click it. Okay, it can't find a single thing. The next one I click is the failure. Why did I get undefined there? You know why I got undefined? Because I tried to pick a random cell type out of an empty list. And then it set that cell to undefined. That's why. So, because there's no allowed types, allowed cell types list, random cell type, cell index. Let's just see what comes up here. Okay, we take those steps. Oh, that was empty too. No, see, now it fails. And the reason it did that undefined, empty, which means that we got a 0, but 0 of an empty array is undefined. It doesn't know how to handle that. So what I'm going to do here to fix that is I'm just going to say, or empty. That basically says if this value is a falsy value, then just use the empty instead. So that should fix that problem. It'll just leave it as empty, which isn't ideal, but at least it won't crash. So let's see now. Okay, now it doesn't crash. Now it goes on, does some beaches. Cool. All right, so the thought that we're getting is in between an ocean and a mountain, right, is going to be flatland. So what I think what this algorithm could definitely benefit from is just a default tile type. A default tile that if it cannot figure out what else should go there, it just picks that tile. And grass biome I kind of like. So what I'm going to do is I'm just going to const default tile equals grassland. Now we're going to have to come up with some rules for grassland too. All right. So let's make grassland, okay. Grassland equals 5, okay. Now we got to pull this in here, and I'm just going to use a brighter green for it. What are the rules for grassland? Well, we can make grassland act like empty and just let it touch everything. That might be good. Grassland. Land. And let's just put every single tile type can go in there. Now here's the fun part. Nothing allows grassland to touch it, but grassland can touch everything, which means that we can generate a default grassland if nothing else goes there, but it won't show up in any other case. Could be interesting. And now instead of empty, I want to use default tile. Grassland is not defined. I mean, it's definitely defined right there. What do you want from me? Okay, we're going to take some steps. Step through. Grassland. But, oh, another grassland because there was ocean in between there. So notice, the only time that grassland shows up is when nothing else could go there. This is going to be an extremely strange looking mountain at this point. But we got a lot of water. So now we have grassland as kind of that default. Like here's some grassland. It's there. It exists if nothing else works. The important thing about grassland is it can be anything at all. Any tile type can touch grassland. It loves everyone. It doesn't mind. Nothing loves grassland though. So if I'm trying to, let's say I'm here and I'm looking at this particular tile, that's never going to be grassland. Ocean does not want to be next to grassland. The only time ocean will be next to grassland is if it absolutely has to and nothing else fits. This is probably going to be a beach or an ocean. No, it's an ocean. Same here, but it's never going to be grassland. So now what I want to do is I actually want to take out those set cells there and just let it run. Okay. Oops. Run the whole way. Oh my god. I went off the deep end. Maybe we should prevent it from doing that. But here, yeah. Kind of a cool little map, right? We got some beach. We got a couple little mountains here. No grassland showed up on this one because it didn't have to. But now what I'm tired of clicking this take step button. I just kind of want to regenerate the thing. But the first thing I want to fix is this problem. Going off the end. Which means I have my get width. I also need to get height. So that I can know if I've gone off the end. And then I'm just going to return map.length because that's the height of the map. I'm going to pull this into my use collapse in a similar way. Get height. And now when I get down here, or actually here, to my move next cell, see? We put this into a helper method, so now we only have to modify it once here. So what do we do now? We say, okay, if current y plus 1 is greater than get height, what are we supposed to do? Well, we're kind of done in that case, right? So let's actually put a flag for that. Const finished. Use state false. And at this point, we set finished to true. Done. Algorithm's over. I forgot to rename it to get height. Did I? I sure did. Good catch. Get height, get width. Yeah. So now if we're finished, here's the next thing we can do. We say if finished, return. Nothing to do. We're done. We're finished. So now we hit this, take a bunch of steps. All right, we're almost at the end. Take step, take step. It still crashes. I think the reason for that is because it crashes before it gets to move to next cell. It tries to handle that cell off the screen. So I'm actually going to set this to, and this is, if you're debugging through array stuff, sometimes you just need to switch it with an equal sign. Or a -1, right? So maybe I just put a -1 on it, and I think that will work. And let's see. Go through it again. Okay, next. Yep, doesn't do anything now. I click on it a bunch, nothing happens. We have our map. Now I want to have a button that just regenerates the whole map. One other button here. And I'm going to say generate. Okay. So now what I want to do, collapse here. It's cool. But I want to be able to do multiple things with this collapse. So I'm actually going to call this const take step. Okay, and then I'm going to return an object that has take step in it. So this hook now returns an object containing a function. And I can come in here, take step, come down here, take step. What did I not like about that? Collapse is not defined. I mean, that's fair. Collapse is not defined. Get rid of that. Now I come in here, and I click that take step, and it still does the same thing, but now my hook returns multiple functions. Because now I can come in here, and I can define another function. Const take step, I'm going to say, okay, const generate map. All right, so generate map, what's it going to do? Well, what I want it to do is I kind of want to do all this stuff in one go. And that's going to be a little difficult because of the way I've set it up. We've got our current x, we've got our current y. That's set up a little funny. All right, we got our whole algorithm here. This is one of the few cases where I'd probably just duplicate this algorithm. There's a way to make this work. I don't care about finished at this point, really, though. I could try to like call take step inside generate map. That could work. But what I'm going to do is I'm just going to duplicate this, grab this whole algorithm. And it's a little wasteful, and I think there's a way to make it a little bit better. But basically, I'm just going to do a for loop here. I'm going to say for row equals 0, row is less than get height, row plus plus, for const call equals 0, call is less than get width, call plus plus. And then I'm just going to paste my algorithm inside that. At this point then, move to next cell just becomes continue, because I just skipped that loop. I don't need this one because it's going to do that automatically. Current x, current y. I'm just going to be lazy about it. Current x equals call, current y equals row. This might work. And you can see the structure of the algorithm is the same, but I have to do different stuff to it because I'm handling this stuff differently. All right, and this is going to break in a very important way because of the way that get cell is set up, but I want to just try it out. Okay, generate. Oh, I need to hook it up. Generate on click equals generate map. And then let's pull that in from our use. Generate map. All right, refresh that. We click generate, and it's like, what? Constant value. Oh, yeah, because I made this a constant instead of a let. Oh, thanks, JavaScript. I forget which language this works in, but like, I always get this wrong. This needs to be lets because you're incrementing it here. Okay, let's try that again. Okay. Kind of cool. Not too bad. It actually kind of lose the end here, don't we? This little chunklet over here. And that's because I think this again needs to be that equals get height. Let's try that. Oh no, that's not the height, that's the width. So let's try that. Let's see. There we go. Now we're getting all sorts of weird stuff though. This should definitely not be there. This should definitely not be there. That's not okay. The reason this is happening, you remember when we did our set cell and we said, look, we need to set cell off of the current map. Same problem with get cell. Get cell is just running off of this map. Whenever we call set cell, it hasn't reloaded yet. So what we can do here is we could do a couple things. One, we could make a full copy of the map in here and just modify it on the fly and then remember what we did. That might not be too bad. But I kind of like this get cell and set cell stuff that we got here. This is helpful. This is useful. So another JavaScript thing we can do is we can use a reference. And what a reference is a reference is basically an object that doesn't change across renders. And what that means is it keeps what we call referential linkage. So right now, I call set map. That changes an object that is not this map. So if I call get cell on this map after changing it, it will not have the new changes because it's a different object. If I turn this into a reference though, then it will change. Or it will keep those changes because technically the reference object is not changing. It's keeping as the same object. So if I do that then, this is going to be map ref equals use reference or use ref empty. So first of all, an init map, let's take a look. of what mapref looks like. It just crashed all over the place. Right, because map is actually going to be mapref.current, and I'll get into why that is in a second. So this is what the mapref looks like. It's an object that has a current property. This object never changes. It will always be the same object, which means you can refer to it across renders, or if you haven't re-rendered yet, and it will have updated the value. References are more complicated to work with than state. However, references are more powerful than state because they don't have the issue that we just ran into. We had that array. So now what we have to do is, instead of this set map, we're going to say mapref.current equals new map. Okay. And this actually should start out as null, I believe, because that's what we set it to. Notice we're not calling set anymore. Problem with that, references do not cause the system to re-render. React doesn't know when they've changed. React will not re-render them. I can use this little trick here to make it re-render. That's a thing I can do. But if I call generate on that, it'll just die. Well, it dies for other reasons. Let's see. So let's go in here now. Set map now becomes, okay, we've still got our new map and all that stuff, but now it's just mapref.current equals new map. Our get cell becomes mapref.current. So basically every place we use map, we switch it to mapref.current. We go here, 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 and here. Cool. Our state is updated. Do we crash again? We do crash. Current map is not defined. Map context JS34. That's fair. Because yeah. This is also mapref.current. Everything. So now we generate. Nothing's happening. There's nothing happening. And the reason is, if we go in here and we're like, well, set cell, what's going on here? Let's check our set cell. Let's console log mapref.current. Okay, and let's just see what the last one is. See if it has value. See if it has data. Generate. Oh, it has data, all right. That looks like perfectly good data. It's not telling the system to re-render. Right? That's the problem. References do not automatically re-render. So how do we handle that? Another hook. So we're going to make a hook here. Use render. And this is going to be very, very simple. Okay? Default function. This function is going to have a state. Counter. Set counter. Use state 0. It's then going to have a function. The only thing this function does, set counter plus 1. Whenever you call this function, it will increment this state. React does not know that we are not using this state anywhere. All it knows is that state was updated and therefore it needs to re-render. So now if I come into map context here, I can import that. Up here, utils, use render. It's a function, so I just call it render, which use render. And then whenever I set cell, I just call render. Even though I'm using the reference, it will still render. This is kind of shitty. The other thing that you can do is you keep 2 copies of the map. One of them is a state and the other one is the reference to the state. That is the kind of better way of doing it, but it's also a little messy because you have to keep those 2 things in check. Now I go here, I generate, and if I generate again, it just fucks up because it's already finished. So generation then, the thing is, we can call set cell a lot of times. Every time we call render, it's going to increment this. but it's not actually going to re-render until we finish our current batch of operation. So we just called setCell 25 times. That doesn't mean we re-rendered 25 times. We re-rendered once, because React batches all of those state changes together and only does it at the very end. So what I can do then, if I'm generating the map, I actually can first go through and set the whole thing to empty. Set cell, call row, empty. So this will blank out the whole map, and then I run through this whole thing, and you know what? It's still O of n squared. It's kind of slow though. Generate, generate, generate. Now every time I click it, I get a totally different map. Very cool, huh? Yeah. A lot of beaches on that one. So, let me see. Where did that come from? 24. I don't want that in there. Yeah, I think it's pretty cool. And the other thing, like sometimes your use render, this is just a counter. It's an integer counter. The thing is, JavaScript can go up to 64 bits, which is like 24 quadrillion, like some really large number. And you're just storing it. It's wasteful because you're storing an extra value here. In the grand scheme of things, it doesn't matter that much because you can reuse this same counter in a bunch of different places and it'll be the same value. So every time you call use render, it's not like it makes a new 64-bit number. It uses the same old one. It does mean that you can handle about 24 quintillion re-renders, but the average application is not going to have that many re-renders, or at least you're not going to be calling this that many times. The fact that we're calling it inside of the map context does mean it's being incremented for every single cell you're doing. So it kind of depends on how many maps you generate. If you wanted to get around that, you could just say if the counter is above a certain value, just reset it to 0, and that will be sufficient to do a re-render as well. So I could say like if counter is above a large number, set counter 0. You know, otherwise set counter there, and then it'll just loop for perpetuity. No one clip that, please. So we have our map, generate a map, new maps. A lot of mountains on that one, huh? Let's try a bigger map. Shrink this a little bit. Let's make it so the user can set the map, right? That sounds kind of cool. So let's say const, let's set up some stuff. Width, height, set width goes use state 5. Okay. And then I'm going to put this in here as height and set height. So I'm declaring two different variables, width and height, in their state. I'm going to change this use effect. I'm going to say use width and height. In the beginning, that's not going to change anything. It's still going to be a 5 by 5. What I want to be able to do is I want to give the user the ability to set these. So I'm going to come down here. I'm going to make a nice little div here. I'm going to say span width. And then I'm going to make an input. Input value equals width. All right, width, cool. You provide a value property to a form without an onChange handler. This will render a read-only field, and in fact, if I try to type into this, I can't do anything. I'm typing right now. Because that's how React handles inputs if you only give it a value but no onChange. So what I want to do with my onChange is I have my event, and I'm going to call set width e.event.target. The event target is going to be the input value. What that's going to do is every time I type a key into here, it's going to go up and it's going to set that width to that new value that I just changed it to. which is then going to re-render the component, taking that new value and putting it back into the value here, which causes React to update the shadow DOM, which causes it to update the actual DOM. Kind of weird, but it works. Now I can type. Okay. Blah, 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 blah. Blah, blah, blah. I probably shouldn't put numbers in there. That didn't do anything, though. When I typed in width, it's not changing anything, right? Reason is this init never happens again. But if I put width in here, every time this width changes, the map will be redone. So that's not what I want. I go here. Okay, I'm going to put this into 15. And now let's take a look at my table. Oh, it didn't do anything at all. Maybe I screwed something up. Oh, you know why? I think because it can't initialize itself twice. That's what it is. I think the init map. Oh, no, it should. It should be doing that, right? So maybe. Let's just make sure it gets called, because it should be getting called now. Basically, whenever I update that width, this use effect should fire again with that new value. So let's see what's going on here. 5, 5, 10. Okay, so it does put in 10. Oh, you know why? You see how this is a very subtle thing. It's a string. That's a string value. And loops do not do well with string values. So what I actually need to do on this set is I need to parse int. I need to parse it into an integer. And then that should work. So now I go here. Let's try that again. Oh, well, that's fair. I can't parse that into an integer. So then maybe what I'll do is I'll take the parsing out here. And I'll put it up here. Let's say parse int width. This is still going to give me a problem if I do an empty thing on it. It will kind of explode a little bit. So if I undo that, see, it's not a number. But if I put 10, now it should be a little bit bigger. Yeah? Still not. Why though? This definitely said 10 came in here as a number. So let's see. We've got our width. Rotate up, push empty. New map that push data. Map for that portion. Oh, you know why? It's not re-rendering. Because set is set up true. It was already true. It was already true. So, because it was already true, the system didn't re-render. So what I need is init map also actually needs to call render. Like that. TypeScript for the win. Yeah, TypeScript would have fixed that. All right. Okay, so let's try this now. Now you see it did actually do something. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I generate this, I get a much wider map. Let's do the same thing for the height. I'm basically just going to copy this whole div because it's going to be the same thing. Height. Height. Set height. That'll change that. Now up here, I need to make sure height is in there, but I also need to parse int height. Okay. So now I'm like, yeah, I would like 25 by 25 map. Ooh. You can notice the table is actually starting to compress a little bit at this point. Let's go back to 20 by 20. There we go. That's kind of a nice looking map. We got some oceans and beaches, a lot of mountains actually, quite a lot of mountains. That looks like a pretty cool map. We could generate again. A lot more ocean this time. Generate again. Cool. I like that. Anyone have any questions on this so far? Oh, wait a minute. Personally, all makes sense. Well, you know, if it makes sense, that's good for me. Hopefully it makes sense to other people. If it doesn't, you know, then please let me know. If you have multipliers for the ocean, what do you mean by multiplier for the ocean? That does sound kind of intriguing. Oh, if you have water, the next block is more likely to be water. Yeah, I could see that. That could be kind of interesting, like a weight on each one. So if I was going to do that, I would basically, in the rule set here, I would make this, rather than an array, I would make it another object. And the instead of just having this, I would have each be the key map to like kind of a weight. And then when you're doing your random number generation, you just weight the numbers based on that. And then you can choose kind of which one you want to see more likely. Like, yeah, you could say an ocean is much more likely to see water next to it than a beach. But a beach is very likely to see a forest, for instance. And that's kind of, if you've ever generated a world like in Valheim or Minecraft, and you've tweaked parameters on it, that's kind of what they're doing there. They're tweaking those parameters of how likely those things are to show up. Yeah. So let me show you then. Because, see, the fact is, as soon as I type this, the whole thing goes blank. I don't really want that. I kind of want it to wait for me to stop typing before it takes the change, right? Before it takes that effect. Because, like, maybe I'm typing something long, and I don't want it to immediately take effect, because it's just, the system changes, and everything changes state. Well, what you do in that case is, instead of just setting the width immediately, you have a temporary variable. Temp width. Okay? And now this becomes the temp width. It sets the temp width. And then you add an onBlur event. OnBlur is when you click out of the input. Okay, so I'm going to put a console log here. OnBlur. Right, so I start typing in here. Typing, stuff like that. As soon as I click out, I get that OnBlur. Click in, click out. Click in, click out. So on the click out is when you can commit your changes. So at this point, then I can say set width, temp width. Okay. Now if I go in here and I say, okay, I got 5, backspace, 40, it has not changed anything until I put this here. You can't, because see, if I get rid of this on change and I say set width and then event, and I change that like event.target.value, and I just get rid of this on change thing totally, it becomes uneditable. I can't edit it anymore. So you have to have both. The on change is very important, so you can actually modify the field that you're seeing. The on blur is important if you want to kind of delay that set. So yeah, you need both. What we often do in this case, okay, is we actually create a component for it. So I'm going to create a components directory. And what I usually put in components, the components folder, are generic items that aren't really tied to any one part of the app, but I might want to use in multiple places. Then I'm going to make a text input. Okay, I'm going to input React, even though maybe I don't need to because of V. I'm going to export the function input. Okay, and then I'm going to put that whole thing of state. I'm going to put my state here. Temp value equals use state. And we'll just set it to blank for now. There we go. What am I missing here? Oh, function. Then I'm just going to return input value equals temp value. On change equals, I'm just going to use E for short, set temp value, e.target.value. And what that does now is I can now take, instead of having this whole input thing in here and all these extra states, I can just say text input. and just get rid of this thing entirely. Oh, text input has an error somewhere. Input, change. Where do you have an error, text input? Why do you have an error? I dislike your error. Line 6. What is this? Oh god, that's the actual compiled stuff. I don't want to see that. Unexpected token at line 610. You know what it was? JSX. Vite didn't compile it. Fun. Okay. Anyway, so now I have this. I can type in it. And I don't have those state values, right? So then I'm going to put an actual like on blur on here. And then I'm just going to say on blur equals. Wow, this is starting to look nasty. Let's make new lines for this. And then I just call my on blur handler with the temp value. Now in here, I could get to say an on blur equals set width. And I can get rid of this temp completely. Okay, because now I change this to 20. I click there, it's done. I change it to 2, click there. So it's the same kind of idea, except you've wrapped it in a component. And so now I don't need to have to keep adding double like temporary variables every single time I want to change this stuff. I can get that same functionality by just putting it into a component. So in fact, in a lot of places, it's very common to see every single standard HTML form, like checkboxes, radio buttons, text areas, all that stuff, drop-downs, wrapped in React components so that you can do various little things like this. We want to do our height. Same thing, but set height. Done. Much cleaner, and at the top level, if you're looking at the input with all that stuff, it's very confusing as to what it's doing. But if you just see text input, okay, you know what that is. One thing, though, is now it's not starting out with those actually populated. You can actually put a value in here. So put that in there, and then in here, value, and that becomes your initial use state. The thing with use state is that it's not going to update this. It's going to take this value as its initial state, but every time after that, it's going to be the temp value. So now you've got that 5 to start out with, but every time you change it, it doesn't matter. I don't know how much of that you guys got. Let me know if you need me to explain that again. But that's basically, you give it the value and that sets the initial value. And then after that, the temporary state takes over and starts using it. You can also use an effect if you want to actually handle when the value changes, updating your state to match. You can put a use effect inside text input that listens for that. I'm not going to do that in this case because I don't need it. Yeah. Let's see. What else do we want to do with this? We've got the ability to change the width. We can change the height. Oh boy. Components changing uncontrolled input to be controlled. That is, I don't know. That's a special one. I think that's if you pass null into a value. There we go. We got a lot of beach on that one. More mountains, a little bit of both. I think it's kind of funny, those beaches that show up with like this beach here. Like there's just a beach there and no ocean. Yeah, we could probably get away around that by being like, forests are not allowed to generate beaches, only oceans are allowed to generate beaches. But then we also mean that if we start off and we never random an ocean, then we never get ocean. Because there's no other way to get ocean. But yeah, I kind of like some of these. Maybe let's try a really big one. Let's see how long it takes. So what I want to do is I'm actually going to drop this size down a little bit. Okay. So now you can see much, much smaller there. And I actually want to do 100 by 100. That took a little while. That took like about a second. That's kind of interesting. You could start to see like patterns repeating. We get a lot of mountains, don't we? Yeah, maybe I would want to tweak that so we have less mountains because we got some really big mountain ranges there, and like not a lot of ocean. It doesn't seem like ocean generates as much. I think the most common thing here is the beach. Let's try another one. Kind of about the same. And you can imagine after a while, the thing that's also kind of funny to me is they seem to generate in these diagonal patterns. Like, that's probably because of the way that we're doing our generation. If you wanted something less like this, you could start in the very middle and do a radix, a spiral, and that would probably give you a different pattern. But I think this is because we're going from top to bottom and from left to right that it gives you that kind of pattern like that. Kind of interesting. I would definitely say this would eventually get repetitive. If I was to play on a map like this, I'd want to add like maybe 3 more tiles at least. And I think that would be kind of interesting. Let me kick this back to something a little bit more, a little more reasonable. Bring that back up to 25. The other thing here is that this still relies directly on the map, but there's not really a ton we can do about that, really. Yeah, that's just kind of how it is. But there you have it. This is basically how wave function collapse works. For those of you who didn't see in the beginning, this is some other examples of what wave function collapse can do. So a lot of good wave function collapse algorithms they'll figure out the rules for you, and they won't always do it perfectly. So we've got these thing here. You gave these example of buildings, and it was able to generate some example buildings. You gave it this example of a plant, it was able to generate some example plants. You give it this example of like some dungeon rooms, it generated some dungeons. And maybe you have to prune this a little bit, but yeah, you get some really cool stuff like this that you can build. And this is from you give it the type of data, and it can extrapolate itself what the rules are. I didn't build that here. If I was going to, I could maybe give it something like this, that like so that it could be clear. Okay, maybe I put ocean next to the beach, but nowhere else, and so it could start to extrapolate those rules. But I didn't want to take that long because I thought that would probably just take too long. But yeah, this is like you can kind of see this goes into really in-depth detail of how it works. There's also a couple of YouTube videos that are really good on wavefront collapse or wave function collapse, excuse me. I just saw it I want to say Friday, and I thought it'd be really cool to take a look at. But there we are. The other thing that you could do if you wanted is take this particular use collapse and allow people to generate these rules and like pass them in here to make it more generic. And then you could actually make this a module. And then you could just use this module. There's better modules out there if you actually want to do wave function collapse. But then you could put this module in NPM, and then you could use it in your other projects. So that can be kind of cool. Actually, I kind of want to take a look at that right now. So what if I do? Okay. Yeah. Well, I'm glad you liked it. Default tile. And I'm just going to take these. So now I'm actually going to remove these from here, and I'm going to pass them into the use. So then in app, inside my use collapse, I'm actually going to pass this in here. And then I'm going to pass in grassland like that. And this should actually be the same thing. Yeah, basically gives me the same thing. Wow, that's a lot of water. And so the only difference there... All right, have a good one, Isaiah. The only difference there is now use collapse doesn't need to know about much of this, right? It doesn't need to know about mountain or forest or grassland. So if I add additional tiles, I only have to put them in app inside my rules here. And that can be kind of nice because if you add a thing and you have to update a bunch of different files to deal with it, it's kind of confusing. So putting it in here just means you're just putting it in one place. Yeah. Any questions on any of this? So I'll wait a little bit for people's questions. You know, of the two people that are still watching. Yeah. I will try to remember to put this up in a repository somewhere, just so that y'all can have access to it and play around with it a little bit if you want. I'll have to see about doing that maybe a little bit later. Do 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 do. All right. Well, I think that's gonna be it for today. Hopefully this gave you a little bit more in depth of how React works, how we handle various situations. Because there's a lot of things, a lot of the little React pitfalls that we ran into here, like for example, needing to update a state twice, um, needing to fetch data from a state in the same kind of cycle as you updated it, handling inputs appropriately if you need to change them, and just hopefully what is I think is a pretty useful or interesting project. We'll try to do maybe some more of these as we go forward and see what we do. All right, folks. Well, I'll wait a little bit for any other questions, and if there's nothing else, then I'll probably end maybe like 2 minutes early. I'll try to put this up there as well. Yeah, absolutely. Thank you for showing up. It's always, you know, it's always better to know that I have an audience that I'm telling this stuff to than just the cold, unfeeling screen. Let's see, we have... Yeah, we only got 3 people watching at this point. All right. Well, if no one has any questions, I think that's where we're going to end it. Thanks for showing up, everyone. And we'll probably be a little earlier in the day next week because I have a conflicting thing that will be at 6. So I don't remember the exact time, but I'll make sure that's in the Discord. Yeah, thanks for being here, folks. And I'll try to make sure to put some this code up and the examples in the description of the VOD when I put it on YouTube. Good luck, and I'll see you next time.